Hi, everyone. Good morning and good afternoon. I'm very excited to welcome you to the annual webinar sponsored by the Crash Modification Factors Clearinghouse team. My name is Matt Hinshaw, and I'm the Federal Highway Administration Program Manager for the CMF Clearinghouse. For today's webinar, we will be practicing what we research: how to apply CMFs in road safety audits, consider CAV's technology, and understand recent federal research. We have a full agenda for you today. I'll get things started by providing an overview of CMFs and the CMF Clearinghouse. Taha Saleem with the University of North Carolina Highway Safety Research Center and manager of the CMF Clearinghouse will provide an overview of the CMF Clearinghouse resources available for your assistance. Kate Bradbury from Parametrix will present on the use of CMFs in a road safety audit for Olympic National Park. Timpone from the Federal Highway Administration's Office of Safety and Raul Avelar from Texas A&M's Transportation Institute will present on a study examining the impacts of connected and automated vehicle technology on our proven safety countermeasures. These will be some very interesting presentations on how CMFs are being practiced in the field. And last but not least, we were going to have Raghavan Srinivasan with the University of North Carolina Highway Safety Research Center, but he had a family emergency come up and won't be able to attend. In his place, Taha will provide an overview of the various current and recently completed CMF-related National Cooperative Highway Research Program projects. We'll save some time at the end for some facilitated questions and answers, and then I'll wrap up with some additional information and directions. Before we get started, I will review a couple of housekeeping items. First, we have muted all participants due to the large number of folks that we have on today. If you have a question during the webinar, please use the Q&A button in the middle of your screen in the Zoom window to open up a box that will allow you to type in your question. You can also see if your question has already been asked first, and we will do our best to answer those here in the Q&A box and at the end, live during our remaining discussion time. Please note that the webinar is being recorded so that we can post it, as well as the presentation PowerPoints, to the CMF Clearinghouse website following the webinar. We will also post answers to other questions that we did not get to during the webinar. Finally, here's a helpful Zoom tip. Choose the speaker view option at the top of your Zoom screen to optimize the screen of the current speaker. If you're having a technical issue during the webinar, you can send a chat to the host and we will do our best to assist. So we also have some questions for you that we'll ask via a poll during the webinar. And starting with this first one to help us determine how many participants we have with us today. So Caroline has got that pulled up here. And please respond to this question and just let us know how many people are attending from your location. I know many of you might be by yourself out there, but many are perhaps in an office with others. Okay, so we'll just give that a few more seconds. And we can go ahead and close that. Okay, yeah, overwhelmingly, 95% of you are out there by yourself. Not a huge surprise there, but we've got some others that are attending in groups of up to 10 or 15 or so. So thank you for sharing about how many people we're able to reach here today. Last item in the introduction, please know that our presentations here today do not necessarily reflect the views and opinions of Federal Highways or the U.S. Department of Transportation, nor do they reflect the official policy of US DOT. So moving on to an overview of the CMF Clearinghouse. Well, we have a mixture of folks out there today and some who are just learning about crash modification factors, or CMFs, for the first time. So what is a crash modification factor? Well, in highway and traffic safety, we have studied the effects that many design, safety, and operations treatments have on how many crashes we experience after the treatment is implemented. A CMF is a multiplicative factor that then reflects the expected safety effectiveness of a countermeasure. With this simple number, we have a data-driven value that we can do so much with. We can use data-driven analysis to compare the expected benefit to cost of project alternatives and have conversations with our peers about how well countermeasures such as curve warning signage, roundabouts, and rumble strips work to improve safety. As we can see from the table, a CMF of 1.0 would indicate no changes in crashes after a countermeasure is installed. A CMF below 1 means that we expect to have a decrease in crashes. A CMF above 1 means that we expect to have an increase in crashes after the treatment or project. We express these often in terms of decimals, but we can also discuss these in terms of percent reduction or increase in crashes. So if we're fortunate enough to have a CMF of 0, we'd expect 100% reduction in crashes. A CMF of 0.8 indicates a 20% reduction in crashes, and a CMF of 1.2 would indicate a 20% increase in crashes. The CMF Clearinghouse is a central repository where we strive to store every CMF that has ever been developed by universities, transportation agencies, and others around the world. It is regularly updated and provides practitioners a way to search for and use the good work you all do to improve safety. We also have information posted on the website for your use in working with and understanding the methodology for analyzing CMFs, as well as links to research, case studies, and trainings. In a bit, Taha will show you a bit more of the website functionality. We're always interested to learn about how you use the CMF Clearinghouse. And so we've got a poll to help us find out just about how often do you use this resource in your day-to-day responsibilities. And if you're attending from a group, if you could just give us a quick estimate of the average in the room, just take an estimate there. Some of you may have, this may be brand new to you. You may have never used the CMF Clearinghouse, and I know we've got some power users out there as well. We'll give that another few seconds here. Okay, if we can go ahead and close the poll. And looks like once or twice a year is most popular. We've got some monthly and weekly users, and 3 of you are daily users of the CMF Clearinghouse. That's outstanding. And about 20% have never used the CMF Clearinghouse, so that's great. We're excited to reach you here today and give you some information that you can go back and use this resource for. So for a CMF to be able to be included in the CMF Clearinghouse, we established criteria in order to help us be as consistent as possible with the data repository. The study where the CMF comes from must be based on crash data. It must have had the objective of quantifying the safety effect of a roadway feature or characteristic. It must be focused on characteristics that are engineering in nature, and the study must have explicitly presented CMF values or functions. Our team here does not derive CMFs directly. And now I will turn it over to Taha to tell you more about the CMF Clearinghouse. Taha?
Thanks, Matt. Give me 1 second. I'm going to share my screen here. Perfect, guys. Well, thanks, Matt. Hi, everyone. So yeah, as Matt mentioned, in the next few slides, we will try to provide you with an overview of the resources that are available on the CMF Clearinghouse for your assistance. So this is the homepage of the CMF Clearinghouse. So basically, when you go to www.cmfclearinghouse.org, this is where you will come. And when I think of it, I think when most folks come to the CMF Clearinghouse, they come here to search for CMFs in the database, and that feature is very prominent in the middle of the screen. However, there are lots of other great resources also available on the CMF Clearinghouse website. And I want to take some time here to show you where you can find some of them without getting into too much detail. So at the top of the CMF Clearinghouse page, you will see 4 headers, namely about the clearinghouse, using CMFs, developing CMFs, and additional resources. We also have feature boxes, which we use to promote the latest and greatest CMF Clearinghouse material. There's, like I said, lots of great information hidden under these headers and feature boxes. So the first header about the clearinghouse, it includes a user guide along with short videos to help you navigate the clearinghouse, search for CMFs, or filter CMFs. There's also a FAQ tab here. So if you ever have a question about anything in the clearinghouse, I encourage you to first come to these FAQs and see if it's answered there. We typically build these FAQs based on the questions we get from our users. So there might be some useful information in those FAQs for you. There's also a star quality rating tab, and this is where you'll find all the information about how we assign the star quality ratings to the CMFs. And then there's also a feature that we added a couple of years ago called data download, or an API, if you're familiar with the terminology. This data download or API tab will allow you to download the entire CMF Clearinghouse database as of that current moment when you download the data. And you can download the data into three formats. It can be either XML, Excel, or CSV format. Now, this is a feature that you would typically use if you're trying to integrate our clearinghouse data into another software or tool that might be helpful to you, or if you're just more comfortable filtering and searching through an Excel file. So even a general user, instead of searching for a search term on the clearinghouse website, you can come here and download the Excel file, and then you can use Excel filter and search functions to search for a CMF that will be most applicable to your scenario. In the Using CMFs tab, as the name implies, it includes resources to help you apply CMFs. There's also a quick reference guide. There's information about trainings, as well as some safety analysis videos that are related to specifically CMFs. In the Developing CMF tabs, we have resources related to developing quality CMFs. But on this page, we also have a CMF most wanted list that I'm not sure many folks are aware of. We update this list every couple of years based on the things that you're searching for but not finding in the clearinghouse, hoping that it might spur some additional research ideas. And lastly, under the last header tab, additional resources, you will find information related to other CMF-related topics, such as SPFs, benefit cost analysis. This is also where you'll find state-specific CMF lists. So if your state has a CMF list, and we are aware of that, we put it in here. Although, if your state has a list and it's not here, but you want us to include it, you can send that to us and we can get that uploaded here for you. So like I said, there is a lot of great information available here on the clearinghouse, and I would encourage you to take some time and explore the resources that are available for you here. I would also want to highlight a couple of ways that you can search the CMF clearinghouse. So the first way is when you come to the home screen, there's a search bar there. You can enter any term related to the treatment that you're looking for, and then you can search by countermeasure name. You can also search the study abstract for that term. You can also search the study citation for that term. There's also an option, if you're looking for a study by a particular author, you can enter the author's name in the search term and select study citation, and it will bring back all the studies that are in the clearinghouse from that specific author. Another popular way to search for clearinghouse is to use a CMF ID. So every CMF in the clearinghouse is assigned a unique ID, and if you have that ID, you can enter that in the search term and just search by the CMF ID. We also have some more slides in the wrap-up of today's webinar, to further guide you towards how to use CMF IDs. Well, so in a gist, right now, currently, we have over 9,000 CMFs in the clearinghouse for well over 800 countermeasures. So that's a lot of CMFs. So entering your search terms will definitely help you narrow the amount of results that you get back. We also have a filter function in the CMF clearinghouse to help you further narrow down the search results. So you can see here that a search for roundabouts would result in about 346 CMFs. Now that 346 number is much less than the 9,000 CMFs that we have in total, but that's still quite a few CMFs to search through to find the one that's most applicable to your situation. To help you with this, you can further filter the countermeasure, the CMFs by the countermeasure category, or on the left toolbar on the search results page is a filter option. So you can filter by various things, including, for example, the star quality rating, the country, the crash type, the crash severity, and even whether or not that CMF was published in the first edition of the Highway Safety Manual. So all of this filtering is designed to help you further reduce the CMFs or further to filter down the number of CMFs based on whatever features are most important to you in finding the CMF that's most applicable to your situation. So say you search on the homepage, you filtered CMFs, and then once you've applied those filters, you're still going to have quite a few CMFs that meet your search criteria. There was another tool that we introduced a few years ago, and it's called the comparison tool. So on the search results page, you can select up to 6 CMFs and you can compare them. So when you select the CMFs that you want to compare and you hit the compare CMFs button, it will return to you a different page, where differences between each CMFs will be highlighted in gray and bold italics text. So here, you can see that I selected 4 CMFs, and the 3 CMFs on the right are by the same author, and they apply to all crash types and all area types. But still, the CMF values are different, and they have different star ratings. So I wonder why they are. And based on this comparison output, we can see that even though they are by the same author, one CMF applies to both 3-leg and 4-leg intersections. One CMF applies to just 3-leg intersections, and the last one only applies to 4-leg intersections. So this distinction here, can help you further select the best CMFs for your application scenario. And once you find the CMF you want, you can click on the CMF value itself, and it will take you to what we call the CMF details page. So the CMF details page, will help you better understand the CMF and the condition that it applies to. So there are some other details also available on the details page, like the date it was added to the clearinghouse. And most importantly, there's also a comment section for every CMF. So the purpose of the comment section is that if our reviewers find something that they think would be of note to our users, they will capture that in the comment section. And it's important for you to see that field to see if there's anything in there that we wanted to bring to your attention when you're looking at the CMF. So now let's take a step forward. When it comes to downloading the CMF from the CMF Clearinghouse, you have 2 options. The first option is to use the export all results function on the search results page to download all CMFs that were relevant or that came up, for your search term. The second option, as we discussed earlier, is a data download or the API functionality that we talked about earlier. And this will allow you to download the complete set of CMFs in the clearinghouse. So now that we've talked about some of the features of the clearinghouse and some of the resources, I would like to remind everyone that last year, the CMF Clearinghouse transitioned to a new rating system that was developed as part of HSRC Project 17-72. This rating system is very detailed and accounts for various factors that our legacy rating system did not account for. At this point, we have a poll question for you. And this is to understand, if people are aware that the rating system of the CMF Clearinghouse changed last year. So you can select yes, no, or not sure. So Caroline, if you can share the search results, you can see what's coming up. That's quite a metric here. So we see about 28% of the people are aware, but about 70% of people were either not aware or they're not sure. Well, and there's a main reason why we want to bring this topic up in today's webinar as well, and guide you to the resources that you can use to understand the new system changes. So when you are on the main homepage of the website, the third feature box here is it talks about the updated ratings, and this is where you can find all the information and all the detailed information on what has changed and how it may impact your work. If you go there, and you have any questions, you're free to reach out to us here, and we can support you, in any way possible to get you accustomed to the new rating system. Yep. So anyway, so these were some of the features of the clearinghouse that I wanted to highlight for all of you. Hopefully you've learned something new or remembered something that was available to you in the clearinghouse through this presentation. I would like to thank you for your time. And if you have any questions for me, you can put them in the Q&A section, and we'll try to get them towards the end of today's webinar. And with that, I would like to turn it over to Kate for her presentation.
Thank you. So I'm Kate Bradbury with Parametrix, and I will be talking about the use of CMFs in a road safety audit that we did for Olympic National Park. I just wanted to note that this work was completed while I was still working with Jacobs Engineering, so just want to put that out there since I recently joined Parametrix. So I'm going to give a brief overview of RSAs, or road safety audits, for those who might not be familiar with the process, since we have quite a number of people on this call. And then I'll talk a little bit about Olympic National Park and the study locations, as well as how we assessed the existing conditions, and key safety observations that led us to proposing countermeasures. And then I'll talk about those countermeasure recommendations and how we use CMFs in that process. So a road safety audit is a formal safety performance examination of an existing or future road or intersection by an experienced, independent, multidisciplinary audit team. And the goal of this process is to identify potential road safety issues and opportunities for improvements, and making sure that you're considering all road users within that context for all of the analysis locations. This is a brief overview of the RSA process. And while the RSA, the thing I want to highlight is while the RSA is conducted by an independent team, input and involvement from the agency, the park in this case, is really crucial to providing significant context and insight so that you can have as much of a complete understanding of the safety conditions as possible. This RSA included a combination of qualitative reviews, so the field work, which is a main component of an RSA, as well as some quantitative IHSDM analysis that we did prior to going out in the field. You know, historical crashes and hotspot considerations are definitely included as part of this process, but it's also not limited to those types of things. And it can also be a very proactive approach that considers both systemic and system-wide treatments, which was something that we really focused on with this RSA. As far as conducting the RSA, when you're in the field, the things that we generally were discussing was looking at how the site might be contributing to higher risk in terms of safety. Sometimes this included consideration of anecdotal observations of where there may be issues, but also what the data that we brought into the field might be telling us. Also assessing or estimating potential contributing factors to observe crashes or key hotspots, again, using that data that we went into the field with was really helpful there. And as well as developing potential safety countermeasures. And that's really like the ultimate product of this process, to provide safety countermeasures that can be viewed in consideration of the context of the park or whatever location you might be looking at. So Olympic National Park, I want to provide just some additional context. Olympic National Park is located on the Olympic Peninsula of Washington State. The park is separated really into kind of two main areas, one that encompasses the Olympic mountain range kind of in the center of the peninsula, and also one that kind of includes almost half of Washington's western coastline. Additionally, recreation areas and park accesses are kind of on the edge of the park and don't necessarily connect in the middle across the mountain range. And there are great distances between these areas to access the different areas of the park. In general, this layout is fairly unique, both when talking about an RSA study area as well as a national park, just because everything is so spread out and doesn't necessarily connect with the other pieces directly. And this layout really leads to a wide variety of environments in terms of weather. So you have coastal storms versus snow and higher and lower elevations. Users, you have unfamiliar and familiar users, driver populations, including local and commuter drivers versus tourists, types of vehicles, you know, people driving RVs that they've rented, or just passenger vehicles or trucks or other vehicles, different types of volumes, as well as other environmental and contextual factors that really play into what is happening in these locations, specifically in safety. All in all, we had 5 priority locations that were identified to include in the RSA. These are shown on the map. 4 are along the outer edge of the core part of the park on the right, and 1 is along the coastal part of the park, a short little section on the left there. And this field work was conducted in March and August of 2020. So prior to going out in the field, we wanted to have a really good idea of where to focus our review and efforts, given that we had a lot of ground to cover. So we reviewed the crash data for all of the locations, looking for trends, identifying key locations within each corridor that really warranted a closer look once we were out in the field. For example, this is showing the first few miles of Hurricane Ridge, which is one of, I think it's the second busiest, might be the first busiest location within Olympic National Park. And, you know, just as an example, we kind of had 4 key takeaways from this data looking at it. A number of crashes occurred at the beginning of the corridor by the Olympic National Park sign, where a lot of people stopped to take pictures. There was a bit of a clustering around the entrance station, which is also adjacent to a campground entrance. Most of the crashes occurred on the first 5 miles prior to the entrance station, where speeds were higher and there were a lot more local and familiar users that were using that portion of the road. And there was also a clustering of crashes at the parking lot at the visitor center at the end of the corridor, where there's also more mixed non-motorized and motorized traffic. So we completed this for all of the locations and use this to go out in the field. In addition to the crash data, though, we also performed an IHSDM analysis for 2 of the corridors, Lake Crescent and Hurricane Ridge. These were the longer and kind of higher priority locations. We used several modules within the software and used the resulting analysis to assign each IHSDM segment with an aggregate score, which were then mapped, which this is showing an example of that. Along with other key components like pullouts and parking areas, tunnels, posted and advisory speeds, driveways, intersections, any of those you know, geometric physical features that could also be contributing factors for the results of what we were seeing here. This helped us also, you know, highlight locations that may have geometric deficiencies or the opportunity to make improvements. So we also use this out in the field for the assessment and to help identify focus locations. So I just want to give a quick run through of some of the key safety things that we saw to give some context for the countermeasure recommendations. So, you know, we identified a number of different things, and these ones here were ones that we kind of identified to be more park-wide concerns that were kind of applicable to every location that we looked at, and likely others that we did not actually look at. So this included speeding, lack of sufficient enforcement personnel. This one was particularly impactful due to the layout of the park and the coverage areas that rangers are expected to cover, and the time and distance it took for them to travel between different locations. Pavement marking quality, guardrail locations, as well as condition, inconsistent warning signs, advisory speed signs, and chevrons, directional arrows, as well as entrance station areas and the design and layout of what was included there. Some of the more location specific things, you know, driver demographics, road departure crashes and clear zone, and, you know, recoverability. You can see some of these pictures here show some of these things too. You know, weather, like I said, very varied across these different locations. Parking and overflow and, you know, trail access, and how that also impacted emergency vehicle access to those locations, as well as horizontal alignment. Pedestrian facilities and vehicle conflicts, limited sight distance and visibility, delineation, sign and post conditions, passing locations and pullouts, and additional signing needs. And, you know, this is just kind of a high level list of all the things we looked at, but you know, we found a number of different things that were pretty varied as well as consistent across all these locations. And so these were all things that were taken into consideration when we developed countermeasure recommendations. So after identifying all of those key safety observations, we looked to use that information to identify and propose potential countermeasures for each item. In total, this ended up being over 90 recommended countermeasures, with about a dozen of those being park-wide or systemic applications. That is a lot of countermeasures, and the size of the park, as well as, you know, limited funding availability really necessitated a prioritization process so that we could help the park identify the most pressing safety concerns and what was feasible with the resources they had, but also kind of identifying what could be tackled quickly and or cheaply, and, you know, what items could kind of have, you know, the most bang for their buck. You know, logically, a benefit cost analysis is a great way to do this. However, you know, given the number of countermeasures we had, but also the types of things that were recommended, they did not always have, you know, applicable CMFs. They didn't necessarily have a way for us to quantify the safety benefit of many of the things that were being proposed. So this really created an obstacle for being able to compare all of the recommendations and prioritize them, since we really couldn't quantify the safety benefit for everything and, you know, compare across every recommendation. So in order to get around this and attempt to compare and prioritize the recommendations, we developed a methodology to create a relative benefit cost, which could compare countermeasures regardless of the available CMFs or data. We used a variation of Harvey balls where half of the circle corresponds with the relative cost and half of the circle corresponds with the relative safety benefit for each countermeasure. Each half had 5 levels of either cost or benefit, which, if it makes more sense to you, you could think of that as like 10 possible points kind of overall for each countermeasure. And so for each countermeasure, we provided a cost score as well as a benefit score. So the benefit score included CMFs whenever those were available, and then we basically just used engineering judgment to fill in any holes there. And then the cost score was based on, you know, bid items when available or other estimates. And then again, you know, kind of just estimated when that information was not available. And then the two scores were combined to create the total relative benefit cost value. And it's a little counterintuitive. So, or they're kind of opposite. So for cost, a more filled in circle actually represents a lower cost. And then for benefit, a more filled in circle represents a higher benefit. So with that, then the totals, more filled in circle represents a higher relative benefit cost value. So to see how this plays out, I just wanted to highlight a couple of examples. So here I've just highlighted a couple. So one of these, I know the text is very small. One of these recommendations was to implement a public information program about providing more information about roadways and, you know, status of roadway and just, you know, what vehicles are allowed on certain roadways, those types of things. This treatment could be completed in the short term for a low cost, but would also likely have a relatively minimal impact on improving roadway safety. So you can see that half the circle is filled in there. And then to compare to that, we proposed increasing enforcement for speeding and distracted driving specifically at key locations that were identified through the RSA. And this also could be a short-term effort that would have a low to medium cost, so a higher cost than the other one when compared to other treatments, but was also estimated to have a medium-high safety benefit. So even though the cost was a little bit higher on this one, it also had a higher safety benefit. So that gave it about a 3/4 filled in circle on that one. just a couple more just to look at some of the other types of things. So we also recommended adding speed tables at entrance station to help slow speeds in those areas. Again, another short-term project that would be low cost, but this would have a really high degree of safety improvement. And so that actually had the highest score of relative benefit cost. And then, just to highlight like a longer term recommendation was higher cost was exploring partnerships with other local law enforcement agencies to provide additional enforcement in key areas, which was estimated to provide a medium level of safety. And so this was only a quarter of that circle, since it was higher cost with a marginal safety benefit. So in summary, with any of these recommendations, it would still be up to the park or whatever agency you're doing the RSA for to decide what would be the most appropriate given the time frame, the available funding, and the benefit to be gained. But this type of summary can be directly usable by an agency as well as with limited technical knowledge because of kind of the simplicity of the output. There's a lot of CMS available and new ones are always being added, but it's still likely that things that you propose will not, that CMS will not capture everything that you're proposing. RSAs in particular, and many other types of projects as well, but may include, more atypical or creative solutions that may impact safety, but aren't quantifiable as of now, or how much of an impact those might have on safety. And many of us have a sense of the relative or general benefit of many of these treatments, though, and particularly when compared to other treatments. So you may not need to know the exact impact, but at least you kind of know, oh, well, in relation to this treatment, I would expect that this would have, more or less safety benefit. And so we can really make the most of that experiential knowledge that we have to help fill in the data gaps and, provide a little bit more of a robust analysis. This approach also creates, easy to understand graphical representation of scores and priority that anyone can use, but it can also be adapted to whatever situation you have. Like you could apply the same approach using numerical scores or some other scoring variation if that works better for your situation. But in general, the approach provides a lot of flexibility while still incorporating all of the data that you have available, but not having that lack of data limit you to not providing, that information as well. So, we had hoped to provide an update on the implementation status of these projects, but due to some turnover at the park, we were unable to get kind of a full or specific update on the status or progress in time for this presentation. But we do know that the data and information for the RSA is actively being used to seek funding and pursue transportation projects in the park. So we, are hopeful to see some of these recommendations that we've provided deployed in the park sometime soon. So if there's any questions, you can put them in the chat box and I'll get to them now or maybe at the end of the presentation. And that's it for me.
Great, thanks, Kate. All right, if you have any questions for Kate's presentation, please go ahead and put them in the Q&A box. We've got a couple coming in there. And now we will turn it over to Karen Timpone with Federal Highways. Karen? And Karen, we're seeing your notes page there. Yeah, if you just go to the display settings, the very top part of your screen. Okay, if you go to the very top where it says display settings on the notes portion, there you go. And we should be able to switch those. Swap, great. And you're still on mute as well. There
Good
we go.
afternoon, everybody. My name is Karen Timpone. Sorry about the little technical difficulties. It's been a whirlwind day with the computers. Anyway, I'm with the Office of Safety, and I am the Connected and Automated Safety Program Manager for the Office of Safety. Let's see. What's happened here?
You go to the bottom left, yep,
Okay.
that works too.
So let me just go over quickly about the agenda. We're going to talk about proven safety countermeasures and talk about how their effectiveness with as we increase more automated and connected vehicles. So the agenda of the presentation today is we're going to look at the overview of the scope of work and talk about the expected outcomes, go through a proposed methodology, high level, and then give some examples of some performance by automation. We performed a gaps and needs analysis, and then we're going to talk about some conclusions and some potential research projects that we'll be working on. So looking at, let's first start out with the SAE automation levels. In order to develop the scope of work for this project, we had to look at how many years that we were going to go out into automation. And we looked at 5 years going out into 5 to 10 years of automation, realizing that levels 4 and 5, which is fully automated, where a vehicle can drive itself with very limited or no driver assistance, would probably be unlikely in our scope of years that we're looking at. So we decided to go from 0 automation to level 3, and level 3 was partial automation, but the driver must be there in order to make any changes. And so then the SAE levels of automated driving, as we first talked, when we first had the slide previously, it was developed in 2014, but lately in 2021 it was updated. So if you could look at this particular graph, it shows a little more detail on how we describe the level of service for automation from 0 to level 5. And as I indicated earlier, we're only looking at 1 to 3. The next slide talks about, we're talking about proven safety countermeasures. In 2008, FHWA began promoting wide use infrastructure-oriented safety treatments and strategies. And over the years, they've looked at adding and developing and putting more countermeasures. I think we first started out with 7. And when this research started, there were 20 countermeasures. Since then, there has been 8 more countermeasures that have been included into the proven countermeasures. But right now, we're only focusing on the first 20. So the task order, we were looking at how does safety countermeasures effectiveness improve or not improve with the addition of connected and automated vehicles. Some of the questions that we looked at, will rumble strips or stripes be relevant? Will they or will they not? Safety edge, curve delineation, pavement markings, what kind of countermeasures that would be effectively unchanged, may change with some enhancements and modifications, remain the same, but may not be less effective or no longer needed in time. Maybe they would cause a problem and effectiveness would decline, or effectiveness may decline, but there's other noted benefits from those particular countermeasures. So this is the way that we were kind of setting up the criteria and looking at the various countermeasures in order to determine how we would proceed with this type of research. So essentially the outcomes of this research were to, document a variable analysis of safety countermeasure effectiveness. Is it still effective with modifications? If not, for various levels of CAV saturation. And then we were looking at documenting a variable analysis of safety countermeasures whose effectiveness could be enhanced with modifications in CAV environment, and looking at those and how, such as smart pavement markings or signal and signing connectivity, or smart road curvature signs. So looking at this, additional outcomes from this is we wanted to look at developing kind of research statements on where we would go, where funds might be developed in the future, where we would develop projects to perform additional research, what kind of investments could we make in order to include connectivity and automation in our safety program. Using, looking at the current level of automation and what projected automation would be in 2030. Vehicles with level 2 automation will increase from 45 million in 2021 to roughly 65 million in 2030. And the same with level 3 capabilities, roughly 2 million in 2030 and 6 million in 2 million in 2022 and 6 million in 2030. So this is kind of an increase of how we're looking at what level of automation will be by 2030. And a lot of this is assumptions and what kind of data we have in order to make those assumptions, but it's been used with subject data experts in current data that we've got from the Automotive Safety Council in order to be able to come up with this particular graph. So looking at a proposed approach on how we wanted to be able to take a look at this, knowing that there's not a lot of quantitative data, and we had to develop some criteria and ways of talking about the data, but using also expert assumptions in order to make those changes. So so we developed a methodology to categorize the chain of causality in crashes and the roles of proven safety countermeasures for conventional vehicle traffic without safety, without CAVs, and then incorporate the expected impacts of CAVs into the chain of causality and estimate the impacts of proven safety countermeasure effectiveness. This is based on expert assessment, based on reasonable assumptions with a panel that we had used for this particular project. And then we estimated the proven safety countermeasure effectiveness for multiple levels of CAV penetration. And you'll see some of those figures as we move forward. Looking at it from a high level, there was two steps in order to produce this. First, we had to estimate the CMF value for SAE levels of automation from 0 to 3 using the current with no automation in 2022 and kind of putting it out to 2030. And we also did this for vehicle to vehicle and vehicle to infrastructure. And then we combined the weighted average of these 5 different estimates that we projected from 2022 to 2030 and given the expected levels of penetration for those years. And challenges that we had when we were doing this particular CMF estimation were assumptions and strengths for safety impacts of CAV. It were informed by an expert panel. So we used, as I had mentioned earlier, the panel included safety and geometric researchers, connected and automated vehicle experts, engineering practitioners familiar with the applications of proven safety countermeasures. So there was a wide variety of subject matter experts on this panel so that we could get an idea on how those assumptions were made, and those were all documented through various levels of documents that we produced, as far as through the documents that we produced as leading up into the gap and needs analysis. So now looking at this, this is kind of a table or a graphic of looking at how we kind of figured out the proposed methodology, looking at a typical chain reaction of a vehicle and coming up with proven safety countermeasures for the 5 different areas, one looking without any automation, one with looking with automation, and then one with looking with automation and V to I, and then VI, and then taking a benefit cost ratio. Now, if we have more questions on this, we have an expert on our panel that can answer questions on this a little bit more. The network relationship was first developed and informed and used by the expert panel. The network is coded in a Bayesian network model that uses crash data to estimate the strength of each relationship. The model is then used to predict the probabilities of the 4 scenarios described above. So that gives you a little idea of how the methodology was developed and used. So next we're looking at the, these are some of the tables that have come out, and then we're looking at how we determine the CMFs for the various automation levels from 0 to 3, and then including V to V and V to I, and coming up with some significant p-values, and then kind of looking at what the projected combined CMFs would be in the future. The colored cells indicate the results that appear significantly different than the baseline value in the same row, and all the colored cells indicate improvement in safety effectiveness. So looking at reduced left turn conflicts at intersections, enhanced delineation at horizontal curves, longitudinal rumble strips and stripes, backplates with reflective borders, corridor access management, and so through. You can see that these would be the particular countermeasures that would be affected by the use of CAV, V to I, and V to V. So next, after performing this analysis, we needed to go back and present this to a group of stakeholders and talk to them about what are potential needs and gaps for research efforts in the Office of Safety, and what do we need to focus and concentrate on in the future in order to take this research that we have used and kind of develop a roadmap and look at where we were headed. The needs assessment had 3 levels of needs that were identified given the analysis. One was connectivity and future safety performance, looking at safety performance for V to V, V to I, and the benefits of V to V, higher levels of penetration, and then looking at cell phone usage and how is that the use of 5G and how that was going to be working out, and then optimize mapping and messaging, and this was all part of the connectivity, and looking at rules of the road for map messages and how that would affect connectivity and the future safety performance. Then we looked at roadmap for future safety investments and kind of where do we see where we could put some financial investments or change some policies in order to take the current countermeasures and make them more viable for connected and automated vehicles. And where could we put this? What kind of research projects could we extend out, and what time frames that we will be looking at in order to do this research and look at it from as a penetration level? As we had more penetration of CAV, how much more research, what kind of research would be developed in order to be able to have some analysis that would be able to change the countermeasures, improve the countermeasures, add new ones. So this is kind of what we were looking at. And then we wanted to look at the opportunities and challenges involving specific countermeasures. And some of those we were looking at was safety edge and pavement markings, what would need to be done for those in order to make it more useful for CAV, and then research needed for green periods and clearance level calculations, and some research on robustness of the detection and negotiating around pedestrians, and looking at corridor access management and how these particular countermeasures with these particular would benefit or not benefit from the use of CAV. From that, we developed some potential research opportunities, looking at connectivity to improve intersection and VRU safety. So intersection-based technologies can play an important role in improve intersection and VRU safety. Sensor modalities, including cameras, lidars, radars, and other infrastructure-based sensors such as inductive loops, weather sensors, and probe data. The primary objectives of this research is to identify feasible solutions that can improve intersection safety for road users, including via VRUs. Number two, the objective of this research is to study and estimate the critical point where the proportion of the SAE J3016 level 2 vehicles reach certain density, such as a list of current proven countermeasures could be updated, specific enhancements, or so that we support AV deployment while we're increasing safety throughout all users. And then looking into the data needs, these research would identify data needs and develop an analytical framework to assess changing safety performance from the PSCs to CAV increases the share of a mixed fleet environment. The research will focus on levels 1 through 3 vehicles. Additionally, this research will produce guidelines for transportation agencies regarding data needs in order to ensure comprehensive safety evaluations for PSCs, given increasing presence of CAV in the near future. And then research, next we have research which would synthesize and be available research policies related to infrastructure-based enhancements to support CAV deployment. And so it'd be some guidelines and considerations that we would look. And then knowing that speed management is been a big problem in crashes, we're looking at automated vehicles can read and obey speed limits. Connected vehicles cannot read speed limit signs, but they have an increasing connection to the infrastructure that can be further controlled by geocoded areas defined with different or even variable speed limits. So looking at some potential research for speed management, and then looking at guidelines for the agency to support rules of the road with automatic driving systems. And finally, the objective of looking at research to evaluate the needs of machine vision systems being deployed in level 2 vehicles today. And if possible, the next generation of machine vision. This research will focus on identifying pavement marking criteria needed to maintain robust detection under daylight and nighttime driving conditions. So these particular research problem statements will be something that we will use in order to work on developing our roadmap through the future, potential NCHRP problem statements, and from this, the final thing that in this project, it's been a 2-year project, and it's we're working on developing the final report. I think I skipped a slide earlier, and it basically what we were talking about with this particular project is we've done some literature reviews if anyone's interested. We've developed some criteria, and then we've also put together the gap in needs analysis, which I spoke about earlier, that was that we used in order to develop these research needs and where we would move for the future. So if you have any questions, please feel free to put those in the chat in the question and answer box. These are the individuals that you would contact. We have Raul Avelar from TTI, that was our lead research engineer working on this particular project. Abdullah Zinedine from the Office of Safety, and then myself. If you have any questions, please feel free to contact us. Thank you.
Thanks, Karen. Let me bring up my screen, guys. Perfect, guys. So now, we have a few slides here to give you a brief overview of current and recently completed CMF-related NCHRP projects. So we will talk about 4 NCHRP projects, including one project that was completed in 2017, NCHRP 17-63, which looked at the guidance for the development and application of CMFs. So this project was completed in 2017, but the materials from this project were only published in 2022. It was only recently that they were published. And then we will also talk about 3 ongoing NCHRP research projects that are all led by HSRC. The first would be NCHRP 17-95, which is looking at developing CMFs for ITS applications. And this is slated for completion in 2023. We'll also talk about NCHRP 17-104, which is slated for completion in 2025. And we will also talk about NCHRP 17-108, which looks at developing CMFs for alternative intersections, which is slated for completion in 2025. So when we talk about 1763, the main research products from NCHRP 1763 were a procedure for estimating the effects of a proposed treatment at a subject site. Also, the procedure for estimating the combined safety effects of 2 treatments, and also guidance for developing crash modification functions. This project also developed a CMF software and a CMF combination tool to support the procedures that were presented in the report. So this project, as I mentioned earlier, was completed in 2017 and was led by Daniel Carter, who is now with NCDOT. NCHRP recently published the materials from NCHRP 17-63 as part of NCHRP Research Report 991. And I have the link to that report on this slide as well. There are also several videos that explain the procedures that were developed in NCHRP 17-63, which were developed with support from Federal Highway. And those videos can also be found in the links that are present on the slides. So as was mentioned by Matt earlier, these slides will all be shared with you on the CMF Clearinghouse website, so you don't have to copy these links down right now. You will all have access to the slides where you can get these links out if you want to. So we have one poll question here for you right now, which we would like to use to understand how your agency estimates the combined safety effect of 2 treatments. So you can select one or 2 or both options, which applies to you. Caroline, if you can close the poll and bring up the poll results. So it's good to see, about 72% of you used engineering judgment, and about 48% of you used procedures based on NCHRP 17-63, which shows that you are all aware, mostly about the 1763 report and the procedures. So it's good to know. Perfect. So going ahead now, for NCHRP 17-95 now, the main objective of this project, is to develop CMFs for 5 commonly deployed ITS treatments. And those 5 treatments are variable and dynamic message signs, CCTV cameras, traffic monitoring stations, ramp meters, and road weather information systems, RWIS. So for this project currently, the phase 1 has been completed, which included, the lit review, a survey of the states, and also data assessment. And currently we are in phase 2, where we are currently in the process of using data from Utah, Pennsylvania, Arizona, and possibly 1 other state to develop CMFs for those 5 ITS treatments that we mentioned in the last slide. So that's where this project stands currently. So for 17104, the main objectives are to validate roadside SPFs and associated CMFs that were developed as part of HSRC project 17-54. We would also develop or enhance roadside SPFs to supplement or replace existing models. And the last objective here is also to coordinate the research products with planner content for manuals such as the Green Book or the Roadway Design Guide. So this project started in September 2022. It's a 3-year project. It's slated for completion in 2025. So when we talk about current activities, we have thus far completed the lit review and have developed a survey to determine the availability of data. The survey will be sent out to state DOTs and safety engineers by sometime next week. Other ongoing tasks, in this project that we are currently working on include reviewing the SPFs and CMFs that were estimated in project 17-54, and also assessing the data that was compiled in other studies. And the last project that I would like to talk about is in CHRP 17-108. The main objective here is to develop SPFs, CMFs, and crash severity distributions to quantify the safety effects of different alternative intersection types. This project also started in September 2022. It's a 3-year project, which is also slated for completion in 2025. When we talk about the current activities, we have recently completed the review of literature, and we are currently in process of developing a survey to determine the availability of data and state and which alternative intersection designs would states prefer, in their for application. Our goal is to send the survey out to state safety engineers and practitioners sometime in February of 2023. And yeah, so this is all I had, for the brief overview of the few HSRP projects that we have been working on or we have worked on. I want to thank you again for your time. And if you have any questions for me, you can put them in the Q&A section. And our next step here would be to take your questions, as they came in. So Caroline, hopefully you can moderate the Q&A session.
Sure. Thank you, Taha, and all the presenters. And I'm going to start actually with a few questions that have already been answered, and then participants can go and look at them as well, but we'll go ahead and say them verbally as well. So the question was, have you used any, and this is for Kate, have you used any crash cost for the benefit cost analysis? If used, what the cost for KABCO crashes? And Kate, I'm actually going to ask you, if you wouldn't mind, you could read what you wrote, but if you wouldn't mind answering verbally.
Sure. So we did not apply crash costs for this method. The relative benefit cost ratio was purely based on a low to high benefit score and a low to high cost score, which gave us a relative score that could be used for comparison and prioritization. But it did not provide a quantitative benefit cost ratio as you would typically see with a BC analysis. That's not to say that severity definitely couldn't have an impact on, safety, but this was kind of a more simplified approach that allowed for direct comparisons between using whatever level of data we had.
Great, thank you. And a general question that came in at the beginning of the session, and Taha, I'm going to direct this to you. How can two separate studies find different CMF for treatments?
Well, yeah, so this is a very good question, and so it all depends, on the context the study was looking at, on which roadway context the treatments were applied in. It can also depend on, which states the data was used from. So there can be situations, where you can have different CMFs for the same crash types, present. We looked at examples, for roundabout in the beginning and in my presentation, where we showed you, how we can use a compare function to differentiate between those CMFs. And yeah, I think, Karen, the second part of the question too, is it the object to choose the best even when they address the same features? So yeah, so the thing here is, guys, now in the clearinghouse, we report all the CMFs as they come in from the studies. We do not recommend a specific CMF for you to use in your certain use cases. We do provide you, with the star quality ratings, which are based on an objective set of criteria to guide you, towards the quality of the CMF. And we also provide you with all the details of what went into developing the CMF. Our request for what we ask all the users is, to look at all the CMF details and look and review the studies to identify the best CMF for your particular use case. Now, that necessarily does not have to be a 5-star CMF. It can be a 3-star CMF that's most applicable to your scenario as well. I hope I've answered the question here.
Thank you, Taha. The next question I'll choose from the list is a question: are you interested in collaborating with universities who are currently researching on improving intersection and VRU safety using connected systems?
So I'll take that. We do have a VRU safety team that's looking at. I would love if you just passed on your information, and I would provide that information to the safety team. As I remember, most of this is still on a research basis, so that's a potential for developing some research along this area. So if you'd please just go ahead and email your information and a little abstract on what your university is doing, I'll make sure to pass it along.
Great, thank you, Karen. Another question that has already been answered. Kate, looks like you got a lot of them. When, who, why was it decided to do the HSM analysis before the RSA?
Yeah, so that was something that was initially, at least, dictated by the client for this project. But there were a couple of main reasons. So this was a unique case for an RSA, particularly, given the layout that I talked about, and just the size and scope of the area that we were covering, and the distance between those sites, and so even some logistics about being in the field with that, and making sure that we could kind of use that analysis to help us kind of focus our attention a little bit more. But also for the two that we looked at, we already had survey data from projects in those areas. So it kind of reduced the level of effort for that IHSDM analysis a bit. So it wasn't quite as much of a lift to do this type of analysis for that. Now, that's not to say that this is something that's appropriate or applicable or necessary for, every or probably most RSAs, but it definitely gives you an option to provide more detail in certain situations if it can be helpful. And then there is an FHWA document that provides some case studies that use IHSDM in RSAs if people are interested in that.
Great, thank you. And this is one that's been answered, but I'll read it as well. This is for you, Karen. My current vehicle has lane sensing technology. The cameras that read the pavement markings fail in winter weather conditions and often in rainy conditions. How will any of this ever be addressed without putting excessive costs on the vehicles? No additional width of pavement markings would help with that.
So I would say to that, the technology is ever changing, and machine vision, what we used 3 years ago to what we're using now is completely different. And I think the use of LiDAR and cameras will be able to help with these things. Yes, I have a level 2 vehicle, and I experience the same things that you're experiencing. But I think as time goes on, and as we get to level 4 and 5, I think those kind of improvements will be made, and machine vision will be able to take care of that analysis.
Great, thank you. And this question I'm directing to you, Raul, and you've answered it, but if you are just guessing, is it reasonable to have results expressed to the 1,000th place?
Yeah, can you hear me?
Yes.
Yeah, I think I went into the detail there of how that's determined. I guess the difference is the way that you report in engineering by significant digits, and the way we report in statistics that you just have 4 digits after the point. But what matters is what is the standard error of that number you're reporting, right? And then in the end comes a p-value that gives you a sense of, is it just random noise, any difference, or is there a significant systematic difference between the things that you're comparing? So yeah, it's a reporting situation there, and I guess we still we have one of those comments in our report from one of the reviewers, and we may actually put a note in there. I think we did in the latest version. But thanks for the question. I think in this particular case, this is a statistics practice to report number of digits regardless of significance. I hope that helps.
Thank you. And the next question was posed to you, Kate, and you've answered it, but do you have an idea of how many the percentage of RSA countermeasures have on applicable CMFs?
Yeah, so for this project, it was about half-ish, maybe just under half of our countermeasures proposed had an applicable CMF or a range of CMFs. But for any given project, that could vary significantly depending on what you're proposing. But for this one, it was about half.
Great, and I'm just scrolling through a couple more, but if you have not asked a question you would like to, please use the Q&A function in the Zoom platform. We're not going to answer any questions live with a raised hand, so please just direct them to the typed Q&A box. Another one for you, Kate, that was asked, what specific modules were used in your IHSDM review?
We used 4 different modules: the crash prediction module, the design consistency module, driver vehicle module, and the policy review module. We used just the stopping sight distance component of that module.
Okay, here's another one for Raul. When looking at the potential modifications to countermeasures to improve safety outcomes for CAV, are you also investigating the impact of these modifications on conventional vehicles and road users? This may be important given that CAV are likely to coexist with conventional vehicles for a foreseeable future.
Yes, thanks for the question. I think I elaborated a little there, but and the answer is yes, we did. The second step that Karen described is basically bringing in the expected performance of each automation level, combine them, and then have some discussion. Is this additive, or do we have like some interactions here that may change that? But yeah, the idea of the project is try to see how the transition from just a few to not so little a number of connected automated vehicles into the future should impact those infrastructure changes or countermeasures. Excuse me. Yeah. And I think something that I put in the answer there is one way that we looked at other changes that are not infrastructure, which were the focus, but we didn't discard any other things outside of infrastructure. A good example is how we discussed, like, okay, we see that the results suggest connectivity is going to be really helpful. So some of the suggestions we developed there was how can we make this more happen faster, right? And some of that would be leveraging the cell signal that can be used to connect a normal phone and normal vehicle to the infrastructure, and maybe have some protocol, ITS protocol, and that would make effectively a vehicle that doesn't have any manufactured connectivity essentially connected in that sense. So thank you.
Great, and here's another question that just came in. When using CMF, how can we estimate an overall CMF for 2 or more similar safety countermeasures proposed or implemented for a specific location, e.g. widening shoulders and installing shoulder rumble strips?
Yep, and that's a very good question, Caroline. And so in the past, we I think a couple of years ago we had this presentation by Frank Gross, where he talked about combining different CMFs, and of course, there are multiple things that people were doing. They were just summing them up, taking the average of them. So the best solution right now would suggest, now that the 1763 material is live as part of the FHWA report 991, they do have a CMF tool there, where you can easily identify a combined 2 CMFs and get the combined effect of them. So since that's available now publicly, it's best to use that tool to get to that combined CMF rather than doing anything funky there, and trying to just trying to say get an average of them, which might not be right.
Great, thank you.
No.
And I'll address a couple of questions that have been asked. Where can the webinar slides be made available, and will we get continuing education hours for this webinar? The CMF Clearinghouse website is where the recording, the slides, and the answered questions will be posted after the session. The URL is www.cmfclearinghouse.org, which I hope you're very aware of by now, but please go there. And then you will actually get a post-event survey and email from the Zoom webinar system, and that will have a link to the continuing education certificate that you can create if you need that for your 1.5 hours of CE credits. Okay, another question that came through. We have a particular problem with post and rail fences adjacent to the roadside boundary, where the fence rail enters the vehicle passenger cell. Has any research been undertaken on alternative boundary fences, CMFs?
So I do not recall any CMFs that are currently present in the clearinghouse for alternative boundary fences. But that's something we can keep a note, and hopefully add it to our CMF most wanted list going forward. Hopefully that would encourage more researchers to research in this area.
Okay, and there's a request if the CMF tool, the combining CMF tool that you just mentioned, Taha, could you put a link to it in the chat to everyone?
Yes, I can do that. So I'll post a link to the HSRC website where you can download the report and also the tools that come with the report. So let me do that right now.
Okay. And here's another question that we've not answered yet. We just have a couple more minutes, but trying to get all of them. Do we really expect people to allow their CAVs to obey the speed limits? People do not obey speed limits themselves. If their automated vehicle is going too slow, I think people will kick it out of automated mode and take over.
Larry, that's so pessimistic of you. So what I would say is probably for level 3, yes, you will definitely do that. But I think over time, the use of an automated vehicle will be especially with 4 and 5, you might have a little bit where the driver is not driving. You'll have other things that you may. I don't want to encourage distracted driving, but that may be a possibility. But I'm hoping that the use of automation helping to have flow and the flow of the traffic would be more even, so you wouldn't necessarily feel like you were going too slow, but you would be following the flow of traffic. So I'm hoping that that will be something that'll be available for, that will not encourage people to turn off their automation and drive faster because they can't do that. I don't know, Raul, do you have anything a little bit more researchy oriented in that topic area?
Research oriented. No, I think you captured it there, Karen.
So Karen, I think now we have about 5 minutes remaining. If we can turn it over to Matt for the wrap up, and then we can answer the remaining questions and post them online, for the flights and everything else.
Great. Thanks, everybody, for all those great questions. Very interesting presentations today. Yeah, just like Taha said, if there's any other questions we didn't get to, we'll provide written responses and post those to the website. And a big thank you to Kate, Karen, and Raul and Taha for their presentations today. Got just a few more slides here before we close out. One item that we are actively promoting is just to remember to use the CMF IDs in your documentation. So all CMFs in the clearinghouse have a unique CMF ID, and that ID allows users to easily reference the CMF in their reports, studies, presentations, and lets other people quickly find that CMF when searching for it. So, it's very important to properly document what CMFs you used for your project so that others can follow your work later. And each CMF details webpage has a unique URL. The last 4 digits in the URL represent the CMF ID. And it's also located at the top of each CMF details webpage. So you can quickly pull it there and use it in your documentation. You can also search for it in the search function. So to do so, you can type the CMF ID in the search bar and select single CMF ID from the drop-down menu. So just a quick reminder to always cite the site. Sharing the CMF ID when referencing a specific CMF makes for easy future reference for others. I just wanted to mention a couple other upcoming items that we're working on. So we're working on a white paper that will cover some lessons learned when we applied some newer methodology to combine CMFs, as Taha was referencing earlier. And we hope to have that published in mid-2023 to share with you all. Our team is also working on converting the website language to PHP language, which should not affect you, but when complete, we'll also be changing our domain name to come under the dot.gov domain. And we'll give you plenty of heads up about this before it happens and plan to redirect users to the new website for a while. 2 other things, as Caroline mentioned, when you exit the webinar, a brief survey will load, and we just very much appreciate your feedback today on our performance. And following today's webinar, you will receive a follow-up email, and this will include a link to download a printable certificate of attendance for 1 hour of professional development instruction. If there are multiple attendees at your site, please forward this link to the other participants so that they can download and print the certificate with their name. Finally, we wanted to share with this group that there is a brand new web-based and self-paced National Highway Institute course on an introduction to data-driven safety analysis. So if you are new to CMFs and data-driven safety analysis in general, this course is for you. There's several learning outcomes, and as listed here, participants will be able to explain the value of using DDSA to support decision-making, describe the application of DDSA methods to consider safety performance, identify data to support DDSA methods and decisions, communicate the results of DDSA to other transportation and safety professionals, and identify tools and resources to support DDSA. I believe it's an 8-hour course in total, again, self-paced and web-based. So please check that out and share with your newer staff as well. And this course is available with no charge to participants. So that concludes this year's webinar on the CMF Clearinghouse. So on behalf of Federal Highways, again, we thank you to our presenters today for sharing their experiences and practices with us. And thank all of you for taking the time to join us today. So thank you and have a great day and be safe, everyone.